Broadcasting from Boston, Massachusetts, the ARC Digital Transformation Viewpoints podcast is the only podcast dedicated to all things related to digital transformation in energy, industrial, and critical infrastructure applications. The podcast is the creation of the ARC Advisory Group Digital Transformation Practice. ARC advises leading companies on technology trends and market dynamics that affect their business. To engage further, please like and share our podcasts or reach out directly on Twitter at ARC_advisory, or please go to the website at www.arcweb.com.
Welcome to another in ARC's podcast series on industrial AI. Today I'm speaking with Steve Blackwell from AWS about software-defined manufacturing in the era of agentic AI. I think it's really exciting times with agents kind of really making access to the full industrial AI toolbox a reality, and it's moving really fast. But welcome, Steve. Can you perhaps for our audience just let them know your role at AWS, and then we'll jump in.
Yeah, sure. Thank you for having me, Colin. So my role at AWS is I lead our Manufacturing Center of Excellence. So my team owns the business strategy, technology, partners and solutions for us in the manufacturing industry, covering four kind of main areas of manufacturing, which is product engineering and design, smart manufacturing, supply chain, and smart products and services. I've been with Amazon now for just over 7 years, I should say, but been in manufacturing the whole of my career, back in the days when I started as a mechanical engineer. So.
Well, and I'm a chemical engineer, so maybe we've set our bona fides that we have some idea of what manufacturing is.
Yeah.
But let's jump in, because I think let's start with some definitions, perhaps from your viewpoint. What is the core essence of software-defined manufacturing, and how does this differ from what ARC's OT audience knows as software-defined automation, perhaps, right? Which often focuses on software-defined control and virtual PLCs.
Yes. So as we look at the kind of the industry being, transforming, and as software is taking more of a play into kind of the OT world, and especially kind of the virtualization of components, we look at software-defined manufacturing as three layers. So kind of down at kind of the traditional kind of the layer 2, layer 1 area, that's very much kind of what we define as kind of software-defined control, which is kind of like the virtualization of the automation or the virtual PLC. The next layer is what we call software-defined automation, which is really the orchestration and automation of that kind of control layer. How the cloud can actually be used to kind of develop the PLC program, validate that PLC code, or the automation code, and have it kind of deployed down onto the shop floor environment. And then the top layer is what we call software-defined production. And this is really where we see simulation coming in. We've heard about kind of the industrial metaverse. We've got the NVIDIA, Omniverse. Really, this is where we're seeing kind of manufacturers, build those digital twins of their manufacturing facilities, their cells, their production lines, and they really want to start to do kind of those what if kind of analysis of if I increase my line by 5 parts per minute to 8 parts per minute, what does that actually mean? Am I starting going to get bottlenecks? Is my automation equipment going to be able to handle that potential throughput? So that software-defined kind of production has that component of that simulation, but then I think we can see it kind of evolving further to actually be more kind of closed loop. How can potentially real world events like where this supplier has unfortunately not delivered these parts, we've got part shortages, how can we actually feed that down into the production line with that software-defined kind of automation, software-defined kind of control to actually change how stuff is actually happening in real time. So
okay, and it's just as you were speaking there, Steve, I was reflecting on Siemens Realize Live. I was there last week, and we had a lot of discussions about the role of digital twins and kind of closing the loop, and with their acquisition of Altair and a couple of other interesting acquisitions. I'm in the process of writing kind of about really how that potentially comes together. I wasn't calling it software-defined manufacturing, but as you kind of described that, it sounds like it's kind of getting, it's almost, I guess I'll have to think about it a bit more, but it kind of fits in with with much of what we've heard about industrial metaverses and the role of digital twins, but it's closing the loop with software-defined automation and software-defined control, right?
yeah, correct. I mean, if we look at, how, I use the generic term kind of AI, it, has kind of grown from a use case point of view in, manufacturing. I think, a lot of people have been focusing on kind of predictive maintenance or, computer vision for, quality control. And that's really, been the application of machine learning models, either in the cloud or at the edge for those kind of low latency, use cases. But if we kind of evolve that and see how, AI is, growing and being more applicable, it really can start to be, applied in kind of that real time, use cases, potentially where if you look at, closed loop control, if you've got software-defined control, software-defined automation, and you've got an AI model with high levels of kind of, accuracy, you could be looking at, potentially, using your golden batch and, set points, monitoring machines in real time, and you could have that AI model provide kind of, feedback back into the machine to adjust potential parameters, to ensure that you're always adhering to that kind of golden batch and you're not creating, defects and so forth. So, that's just kind of, one example of we see how, AI can start to be used as part of that whole software-defined, manufacturing. And then, as you said, kind of, as you start to look, broader and, go beyond that single use case, how, simulation can be used a lot more of the overarching kind of planning process. So,
all right, yeah, and I'm starting to hear the phrase "software-defined everything," right, as kind of a broader trend. But maybe let's switch gears a bit and kind of make the connection with agentic AI, right? Because I think agentic AI in many ways has kind of freed us from purely chatbots and trying to force them into roles as assistant. I think agentic AI has kind of let us tap into, to your earlier point, all of the different machine learning and neural net and clearly generative AI tools and techniques, but it's letting us tap all of those and kind of create a way of really deploying that at scale. So can you make the connection between SDM and agentic AI for me?
Yeah, I mean, yes. I mean, for us, agentic AI, is one of really kind of a key enabler that's actually going to enable software-defined manufacturing for manufacturers. The good example I always go to is I'll go back to my my predictive maintenance example. If someone's deployed predictive maintenance machine learning model, generally the output of that machine learning model is going to create a value in a dashboard. Okay, dashboards are only great if someone's actually looking at that dashboard. now, but if you truly think of look at manufacturing, in Industry 3.0, automation and robotics really kind of drove, that next level operational efficiency for manufacturers. for me, agentic AI in, industry 4.0 is going to deliver that next level and enable manufacturers to truly get to software-defined manufacturing. So going back to my predictive maintenance example, just see, how agents come into that. So machine learning model, predicts a potential asset is going to fail in the next, couple of months potentially. You can then think of like agents. Okay, so now you've got your input to start kind of a workflow. Agents can now kind of orchestrate across the multiple different systems to go, okay, do we have that, is that a serviceable part? That's going to be retrieved from one system. Do we actually have the spare parts in stock? If we don't, do we need to actually order them? And, do we then need to we've got the parts in the stock, it's going to take, 2 hours to actually complete this one. Let's now create a record in our maintenance system to actually perform that actual maintenance task. So you've got, multiple agents there that you can actually orchestrate to actually truly give the value of predictive maintenance. Because to me, predictive maintenance is not just, a machine learning model predicting that a machine is going to fail. Is actually the whole orchestration to make sure that you've actually done the servicing of the machine or asset to ensure that it doesn't actually fail and stop the line. So, as we're in software-defined manufacturing, agentic AI is really kind of the overarching kind of enabler that brings together all the different parts of AI, the systems of records, the applications to really deliver that value.
Yeah, it seems to be the agent of interoperability, right? It's going to change the game as far as access to systems. And we'll get into maybe some of the technologies and ways that is really being... I've just been amazed at how quickly we've seen all the major infrastructure players, enterprise software players kind of share and adopt open source standards for, I hate to call them standards, but let's just say open source approaches to agent interoperability. But before we get there, maybe talk a little bit more about that. You gave an example of an agent, although I think really in practice that could have been several agents, each with dedicated tasks. So we're usually now, I think, talking about achieving software-defined manufacturing or software-defined everything using a combination of existing systems that are well understood, and you can almost view those as legacy systems of record that are going to get a new lease of life. Because these agents need those systems actually to actually perform actions, or for those agents to monitor what's going on. But it's really a multi-agent orchestration world that we're kind of seeing evolve.
Yeah, agree. I mean, I don't think, I could be wrong, that, those systems of records, those, MES systems, the ERP systems, the MRO, enterprise asset management systems are always going to be needed within manufacturing because the systems of record. But, traditionally they've been very, transactional, what sometimes I call swivel chair, where you're going across multiple screens or multiple applications to perform, a process. Really where, I see the industry going is, agents can take over, that transactional, and that can actually automate going across those multiple systems of records to drive the business process and actually drive that value for manufacturers. Especially when, we all know that, manufacturing has, got a skilled labor shortage, those automating and using agents, to me, is kind of very much a low-hanging fruit, addressing kind of that skilled labor shortage. So
agreed, and I think it's a great point you raise. In fact, that's why I and many of my fellow analysts at ARC are so excited about agentic AI. I'm not going to preach about, I don't like the term agentic AI, but I love agents, AI agents, and I love the multi-agent orchestration paradigm. I just happen to think that it's not really a new type of AI, it's a new architecture that makes use of all the flavors of AI and machine learning, and in some cases, there may not be AI on the other end of that agent, right? It doesn't have to have an AI component. But I think what you're really saying is, the reason for that excitement is that we really see that fragmentation. It hasn't really stabilized that much over the 20-odd years that I've been looking at shop floor systems and factories. It's still a plethora of different systems, point solutions kind of cobbled together. So I'm hoping this is really going to break things open in terms of interoperability in the factory and the factory with the supply chain.
Yes, yeah, I absolutely agree. I mean, yeah, to your point, I think it's going to be very much a combination. Some people call it kind of, multi-model. There is a place for, machine learning to actually do those, the predictions, based on a model that's been trained on a particular data set. The value of large language models is, obviously interoperability of kind of in natural language, but also, interpreting, that data and providing turning data into information. And then kind of those agents to then kind of orchestrate across those multiple systems. So, yeah.
Yeah, and don't get me wrong, I'm very excited about Gen AI, but I think a lot of its value comes from Gen UI, the fact that it is the way that you're interacting with very complex systems now. And it's radically changed how we, the fundamental design. I don't think I've seen a piece of software that hasn't got some form of Gen AI embedded in the UI, whether it's a traditional UI or it's voice-based or video-based, right?
Yeah.
But maybe let's switch gears a little bit, Steve, because I do want to talk about the how, right?
Yes.
So what is AWS's strategy, and what key services or initiatives are empowering your customers and partners to translate the excitement about agentic AI into tangible software-defined manufacturing solutions?
Yeah, sure. So, I think again, I talked about the layer cake at the beginning when I've defined software-defined, manufacturing. Again, when it comes to actually kind of, the how we implement this, at AWS, we're very aware that, some of our, manufacturing customers, have the ability to kind of build or want to build because they're, so complex environment. So that's when like services like, Amazon Bedrock come in. For those that don't know what Amazon Bedrock is, it's one of our generative AI services. It has a marketplace of large language models or foundational models. Everything from Amazon Nova, which is our model, through to Anthropic's, Claude or Llama, for example. And within Amazon Bedrock, we have Amazon Bedrock agents and Amazon Bedrock agent flow, which allows any builder to be able to build their own agentic AI kind of workflow by defining agents and using large language models to do that. Obviously, next up the stack, for those that manufacturers are not actually builders, then we obviously have Amazon Q Business, and Amazon Q Business also has automated workflows. So a graphical user interface designed for a line of business person to be able to build those workflows and orchestrate across those multiple, applications. But then, we have a partner, or partners, I should say, very much that provide capabilities in that space. Composable AI, Articulate are two of our partners that provide, applications to do the same. So they're, available on, AWS. So for those manufacturers that just want to buy a solution and be able to build, agentic AI, workflows, or agentic AI applications, I should say, then they can do that with our partners and so forth. So we're really trying to ensure that, for whatever use case or application, we have the kind of offering to enable them. So,
yeah, and I'm familiar with Composable and Kent Sanderson. I've kind of been a fan of his for a few years. He was kind of one of the first I really heard talk about agents, although the language wasn't agents at the time. It was more about skills, and but he was very early in that cycle, really talking about the fact that you needed to use different AI ML algorithms to build and train specific skills. But of course, he was well prepared for kind of this agentic AI push.
Yeah.
But perhaps talk a little bit about, because we haven't talked about your collaboration with Siemens. As I mentioned earlier, I was kind of at the event last week, but maybe elaborate on what you're doing with Siemens and Siemens Industrial Edge with the AWS Industrial Data Fabric, and how that kind of plays into this vision of software-defined manufacturing.
Yeah, so Siemens has been one of our strategic partners for many years now. I think there's kind of multiple areas we can talk about. When we talk about kind of the industrial edge, and this is really kind of a key component for me. Is, application of AI or agentic AI, can only be done if a customer has their data. And the prerequisite is that they need, have their industrial data available and open. So that's really around the kind of industrial data fabric for us. So providing manufacturers the ability to be able to ingest, store, contextualize, and then be able to act on their data. And this is what we're, talking about as part of agentic AI and software-defined kind of manufacturing. So, Siemens provide, a very key part of that, the IDF architectural framework, especially around the industrial edge and being able to get the data out of all the industrial systems. And also in the case of, if you want to deploy a machine learning model, then you have the ability to do that, that with the industrial edge. But, I think another key part of our collaboration, and this got announced at reInvent with our partnership, is now with TIA, their engineering portal. So very much now focusing on that whole software-defined kind of control point of view, and assisting the manufacturing engineers or the automation engineers to be able to program the PLCs using generative AI. They now can do that on TIA, which actually uses Amazon Bedrock in the background. So this is how kind of we're partnering with them. So they're now developing, or developed, I should say, TIA that uses Amazon Bedrock. So bringing really generative AI to kind of enable, the process engineers, the automation engineers to be able to use it for that software-defined control, software-defined automation layer.
Yeah, and you've triggered another thought, which is having just come back from Realize Live, I was reminded of kind of Siemens' massive footprint in automotive and obviously AWS as well. And it always strikes me as kind of one of the software-defined vehicles kind of are a step above software-defined control, right? But it maybe talk a little bit about what you're doing with major OEMs like Volkswagen and others that I know you're working with, and the intersection, I think, with software-defined vehicles and software-defined manufacturing.
Yeah, I mean, if you look at, just the automotive industry in general and kind of where it's going, I think driven by, two areas, obviously the electrification, but also the in-vehicle kind of customer experience. It's very much going to, it's all software driven, from the, infotainment system to all the multiple, control systems that are actually in a vehicle, from running the motors to, the windows and the HVAC system. And that really, is what the architecture of vehicles have done is they've gone from all these multiple different, ECUs to now consolidating to kind of like someone in the automotive industry is going to correct me here, but a single ECU that's kind of virtualized, has a hypervisor, do you allow it, and then gives the ability for OEMs to be able to constantly update and provide new features and push them down to kind of the the vehicles to enhance, the vehicle's operation, but also, the customer experience. And if you kind of take that same kind of, concept of how we're actually working with, OEMs to obviously, develop, that next generation of vehicles, being able to, virtualize the whole development and testing and validation, of that software for those vehicles by actually virtualizing and running it in the cloud, and kind of really empowering their software development engineers. You can extrapolate that into kind of, manufacturing, and where, manufacturing potentially is going to go with, software defined kind of control. Think of a manufacturer that's actually wanting to build, a brand new kind of factory. Could they, virtualize that whole factory? Could they actually build a digital twin of that factory in the cloud? Could they develop all the automation code? Could they actually then run kind of simulations of how that factory is actually, running, to actually make sure that they've got no bottlenecks, no safety concerns, get the optimal kind of layout before they even kind of lay a single bit of kind of concrete type stuff. So I think there's a lot of learnings and technology that we can take from the automotive industry, like in vehicle, and bring it into kind of manufacturing.
Yeah, it's kind of an extreme example of a smart connected product, right?
Correct. Yeah.
But there's elements we can learn from that and drive at scale. And Siemens would certainly agree with you in terms of they think they can achieve that virtualized digital twin of plants and iterate on the design and simulate just about everything, right?
Yeah.
Now maybe let's we've covered a lot of ground, but I want to make sure we talk about some of the details of perhaps the biggest barrier to the adoption of AI agents at scale, which is kind of the legacy and interoperability issues. And what really triggered my excitement about AI agents was probably when a strategic partner of yours, I believe you got a significant investment in Anthropic, right? When Anthropic kind of offered up Model Context Protocol, I think that was in November last year, so it's not that long ago, but that really triggered kind of a waterfall effect. So for those that don't know, Model Context Protocol, I've got a whole series of blogs on MCP, and then what followed was kind of another hyperscaler and 50 system integrators. So Google, I think we can mention their name. I know you won't be too upset. They did something good, which was kind of promote this idea of agent-to-agent extensions, so that you didn't just understand the context of AI models and the agents that were using them, but the A2A consortium that kind of built around these extensions started to define how agents could talk to each other. And then you very recently, I think it's just a week or two ago, right, announced AWS Strands. So can you maybe just paint that picture of what AWS Strands do? Because I was very excited when you told me about it, because I've been talking about the need for interop and the fact that you need to be able to deploy these agents on the edge and in the cloud, especially for us in the industrial sector. So describe what AWS Strands is and how that fits into the picture.
Yeah, sure. So I'd want to go a little bit back as well, because your point around kind of, MCP, and one of the reasons why, for us, the real value of Industry 4.0, going really back to kind of bare bones, is enabling manufacturers to be able to use their data type thing. And that's why we built IDF, which is, how do we enable manufacturers to bring their data into the cloud and making it open and accessible for whoever needs it, be an ML model, be a thing.
And just a reminder, Steve, because you used IDF and not everyone remembers.
True. So Industrial Data Fabric, yes.
Right,
yeah,
okay.
Okay. But obviously we were talking about kind of systems of record, databases. And I think, again, MCP, gives that ability to even make those applications even more open and accessible. Because if you think of the developers, the people who are actually building this agentic AI, they want the ability to be able to openly access and be able to scale, So obviously with the support of, MCP in, Amazon Q, developer, is really key to, enabling that interoperability across, industrial data fabric and using, Q developer to be able to kind of access all the applications or databases where you can actually use MCP. Obviously, with the launch of AWS Strands, we're really kind of taking that to kind of the next iteration and really trying to kind of simplify and enable and give the ability for developers to be able to really kind of build these agentic AI and kind of applications. So.
Right, and I'm seeing kind of now that I've been talking about this idea of an industrial AI protocol stack, which kind of brings together, MCP servers and clients with agents that can be orchestrated using A2A. But I think, if I recall, Strands is more about building those agents and making them
correct
operate on multi-cloud, right, or on edge devices, which I think is a great addition to that stack. Can you perhaps, if we want to try and, I think, bring this to a close, because we could talk and dig deep into a lot of these topics, right? We may have to do a follow-up, but maybe let's talk about with this, what has really been, over, I guess we're in June, right? So over 7 months, right, we've seen this potentially new industrial AI protocol stack kind of start to shape up with a lot of help from AWS and its support for things like MCP and now Strands. What's next? I mean, I start to look at, with actually hope, I look at the future of factory systems, factory and supply chain. I think supply chain's already talking a lot about AI agents, not just talking about, they're using them, but they kind of had knowledge graphs and kind of they have lots of algorithms that they can kind of use agents and kind of rethink how they orchestrate them, and in some ways solve the traditional siloed applications in their own portfolio with agent technology. But I get more excited about what we could potentially see in terms of the future of things like MES. But I'm not seeing the same rapid pace of adoption yet. Or do you want to give me some thoughts, Steve, on what you think the future of MES is? You kind of hinted at earlier you don't think they're all going to disappear, but I think there may be some evolution that they need to do to kind of survive this wave or new era of agentic AI.
So I think from what we're seeing from at least from an MES perspective is even before kind of agentic AI has been with us, is that manufacturers have been looking at their MES and this large monolithic application that they've had, and they've been more looking at how do we actually make it more composable and very modular based on what we actually kind of need type thing. I'm doing material management, or I'm doing want to do WIP or quality management. But then as we look at manufacturers integrating their industrial IoT platforms into MES applications, And then you then go, okay, so that's now you're getting real-time data feeds that can actually start doing kind of events. How do you actually then start going, okay, well, we've created an event, or, event has happened. What do we do with that event? And to me, kind of the next, evolution of the MES, now it's becoming composable or module, is the integration, or maybe more the kind of an addition of agentic AI. And how do you actually use agentic AI to then actually take that event and do, the process? How can you potentially, start integrating into that automation layer to actually control the actual process, rather than actually, thinking, how does the, traditional kind of MES, done the management, and then you used to have like the DCS, the SCADA systems, there would be communication, but, one would be controlling the shop floor, where one would be kind of, managing type thing. That's not all the case. I know in some areas of process manufacturing, they are more one, but, with agentic AI, in MES, it could be very much, now you've actually kind of got software-defined control, software-defined automation. That MES can become a lot more integrated into the actual running of the shop floor, environment, using agentic AI. Right? That's where I think it's going to be.
Yeah, and I have some of my own opinions, but I will let my fellow analysts that cover the MES space really talk about how they see MES evolving.
Yeah.
But I think there's tremendous opportunity there. I almost see, as you were describing it, the future of MES is really as a multi-agent orchestration platform, and if it doesn't evolve to that, I think they do run some risk of being disintermediated or getting squeezed from both sides. But we've been saying that for 2 decades, right? So, and there's still a number of very strong MES solutions out there. So let's see how that market evolves. Look, I've really enjoyed the conversation, Steve. I think we should perhaps follow up and do some deeper dives on some of these topics. Is there anywhere that you would like to refer our listeners, OT audiences, if they want to learn more about AWS software-defined manufacturing, AWS Industrial Data Fabric? So here's an opportunity for you perhaps to share a couple of places they should go and find more.
So the easiest thing to say is go to aws.amazon.com/manufacturing, and that will take you to our manufacturing specific landing page that will list all kind of our AWS solutions in the manufacturing space, including what we've been talking about today, industrial data fabric, our partners that offer, agentic AI solutions, and blogs talking around, software-defined manufacturing, and such. And then from there, if anyone wants to learn more about, some of our specific services, like, Amazon Bedrock, Amazon Q, then I'll be able to find that from that page as well. So.
Okay, great. Thanks, Steve. And let's schedule a follow-up conversation. I know there's you're continuously evolving the stack. I'm really excited about the work that AWS has done and its commitment to manufacturing. I think we needed some additional competition in that space. I won't say any more than that, but look forward to talking again soon, Steve.
Yes, thank you very much. Thank you for having me here. It's been a pleasure talking to you. Yes, and I'd say this is a very evolving area, so I'm looking forward to see what's coming in the next, months and so forth. So thank you.